You need to pay attention. Okay, so here's what we're looking at. The cover page, I kind of want to get you familiar with a little bit because you need to know a few things that it tells you on there. And a lot of times we just don't find like we have enough time to read the directions. So
yeah.
Make sure. Answer booklet is provided this year. Used to be you wrote on lined paper, like college rule.
Yeah.
But now you actually have an answer booklet.
Okay.
And bless you. Every single question actually has a space for you to do the work. Okay. Yes.
How big is the space?
It's pretty big.
Because, well, like, what if you're running out of room? You know.
They also have continuation booklets, but we prefer you not to use them if you didn't have to.
Yeah.
Try to keep it in one space. They're pretty big spaces. Okay. So if you need additional paper, ask the invigilator for a continuation booklet.
Yeah.
Okay. Yeah, that would be like us. Answer all the questions.
Oh, I didn't know that.
I know. That's a big one. Give non-exact numerical answers to 3 significant figures or 1 decimal place in case of angles. In degrees. In degrees. Unless a different level of accuracy is specified. Yes.
So what is a significant figure defined as?
Like 3 sig figs would be like 1.36.
But like in the case of zeros, like there's some cases like where they're like important but not significant, you know, like
They're important in the middle of numbers.
So if you had 100, the zeros are not important?
I would think they are important if that was...
They're important, not significant, unless it is point something else. If it's like 100.1, then those zeros are between 2 numbers and they become significant.
What about 100.0?
I think because if it's a 0 after a decimal, that becomes significant, and that might turn those other zeros into significant figures too.
Because I know...
So it'd be 100.
Yeah.
So that would be 4 significant. 100.0 might be 4 sig figs. Right?
Oh, so just 100.
Right. It's crazy stuff.
Yeah, but then it becomes 1 sig fig.
What we're going to do is we're just going to...
But yeah, at that point...
Not stress over it. Yeah, try not to stress over it. The use of an electronic calculator is expected where appropriate. You're going to use it the whole time.
Inappropriately use my phone.
I hope you
I'm
do.
going to do 2 plus 2 everywhere.
You are reminded of the need of clear presentation in your answers. So important that they can read your handwriting.
Yes.
And that they don't have to follow arrows to get to the answer. At the end of the exam, fasten all your work together securely. You won't have to because it's going to be in a booklet this time. Okay. The number of marks is given in brackets at the end of each question. You're very familiar with that. And on this particular one, you have a total number of 75 marks. On statistics, is 50 for a total of 125. Yes.
And that's why, like, if you had gotten a 42 out of 75, which isn't that great, you could not even show up for the other tests and you would still pass.
You actually have to show up for the other tests. You have to be participant in order to be...
In theory.
In theory, but not in reality.
You don't have to bring your brain, just your body.
Yeah, you can just draw on the paper.
You wouldn't really know that you got a 42 out of 75 until August, so I wouldn't risk it. Yes.
So you only have to get 40-something right?
Ish. It depends on the year. It ranges. Okay? So now we have all the fun stuff. Let's do this. Okay. Find the term independent of x and the expansion of x minus 3 over 2x to 6. Look familiar?
Yes.
Oh, thank you, Lord. Okay. Does the term word independent throw you off, or are you comfortable?
No. There's no x's attached. It's a constant.
X's attached. It's just a number. Right.
Right.
So, okay, so let's talk a little bit about the best way to do this. You have options. You could do the Pascal's triangle and really, really work hard, or you can use binomial expansion and try to figure out what numbers are going to start to make it break down. So I understand that I have an x and I have a negative 3 over x. Those are my 2 terms. Would you agree?
Yes.
3 over 2x. Did I say that right? Okay, now.
I forgot the 2.
Oh, thank you. Okay, so I said it, but never really meant it. Okay, now, we have things that we need to fill in the blank.
Yes.
Ultimately, ideally, we have to get where the x's cancel themselves out, right? So, what is the n in this particular case?
6.
Does everybody see that?
Yes.
So 6 is our top number, right? And we know this plus this has to equal 6.
Yes.
Good?
So 3 and 3.
Say it again.
3 and 3.
It could be 3 and 3. Let's look.
Let's
Let's see for a moment. If there's a 3 here and a 3 here, do you agree that x to the third would be on top on the numerator, whereas 2x to the third would be in the denominator? So therefore, they're dividing, so therefore you subtract exponents. So 3 minus 3 is 0. That is where it's independent. Yes?
I thought when you expand out a binomial, you have 6 NCR 0, and then it would be x to the 6th, and then negative 3 over 2x to the 0th, and then 1
That's
expands.
the first term.
But how did you know to do the cubes? Because
Because we want the terms that would cancel the top and the bottom out to become independent.
and the only way that to make sure that those are that would be true is that the 3 should add up to the 6.
Right.
Yeah.
Okay, so in this particular case, what's the number down here going to be?
3.
A 3, right? And that number comes from where? Which one?
First.
It actually doesn't in this.
Either one.
It comes from here.
Doesn't matter because there's
They're the same.
There's a rule that says 6 choose k is the same as 6 choose
It's
n
true.
minus k.
Right, same idea. Right.
And n choose k is the same as n over or n choose n minus k.
Right. Okay, so just FYI, just to remind myself of the process to go through. 6 factorial, 6 choose that. You guys are going to be doing it in your calculator, luckily, right?
Yes.
Whereas, I wouldn't. And what's a mistake somebody's going to make?
Square everything.
Yeah, to remember to not square everything, but cube everything.
Cube.
So what is this cubed?
Negative 27.
Yeah, be careful of that. Negative 27 over
8x cubed.
8x cubed. You see that 8 somehow might be
Yeah.
forgotten, right? Okay, so now that we're in a spot where we've got that, let's clean her up a little bit. 6 factorial would be 6, 5, 4, 3, 2, 1. So the 3, 2, 1 would be gone down here, right? Would you agree? So it's 6, 5, 4, 3, 2, 1. Those cancel with that. And then this is really 3, 2, 1, which is the same as 6. That's how I do it. You guys use a calculator. So what I'm left with is 20.
Yep.
I'm left with the x cubes canceling out
Yep.
times negative 27 over 8. Okay? In this particular case, what kind of answer are we going to be looking for?
It's 3 significant figures.
I would think so.
Negative 67.5.
Yep.
Negative 67.5,
That is 3 points.
and you get 3 points.
About 2 seconds over.
What do you think?
That's pretty good.
Now, occasionally it says part I, find the first 3 terms. And then part I, now take this thing and multiply it through. Does that sound familiar?
Uh-huh.
I'm going to find one of those. Remind me, write it somewhere on your notes that we want to go over one of them. Because this is really pretty simplistic for that type of problem. Okay? Are we good so far? Moving on. Number 2. Solve the equation 3 sine squared equals 4 cosine minus 1. Excuse me, between 0 and 360, yes.
Well, you can recognize that sine squared theta is a Pythagorean identity, which is 1 minus cosine squared theta. So now everything's in terms of cosine.
Okay. Is everybody cool with that? Now, question. Typically, this is an I and an II kind of question. The first I would be make this to look like this,
Yes.
right? And then part I would say hence and therefore solve, right? So this one didn't tell you make this one look like this one.
No.
Does that make sense?
Yeah.
So it really wants you to utilize that technique without telling you to utilize the technique. Okay. So everybody feeling the same way now? Can I erase? Okay.
Well, it's on YouTube if they didn't get enough time to write it
That's true.
down.
If they didn't get it in time, they can go watch me. Lucky them. So we have 3 sine squared equals 4 cosine theta minus 1 from 0 to 360. Okay, so you all told me that you recognize the sine squared as a Pythagorean identity.
Yes.
So we're going to clean that up a little bit. Sine squared is equivalent to
1 minus cosine squared.
Yes. Does everybody see that? Remember that?
Yes.
Yeah? Remember, this is given to you on your bright colored sheet of paper. So that's good news. Not something you have to memorize. Yes.
I remember there was a trick to remember the Pythagorean things. They're on the sheet, right?
They are on the sheet.
Alright then. There's still a cool trick that I found that I wanted to share with you.
Okay, cool. Let's do it.
It's you write the sine squared plus cosine squared equals 1, right?
Yeah.
And then you divide all those terms by sine. Sine over sine is 1. Cosine over sine is secant, or cotangent. and then equals 1 over secant is, or 1 over sine is the cosecant. There's the other
Oh,
identity.
you have your
and
other
then divide
identity.
everything by cosine, you get the other identity.
Oh, very cool.
Oh.
Good news is you don't have to memorize it for this test, but later on in the future, when you don't have this class, you probably wouldn't need to know that. That's awesome. Yes?
And I think what you said with the Pythagorean identities is to solve for one in terms of the other, because it could be in any order.
It could be in any order, right. So what you recognize here is that sine squared is important. You recognize it as a Pythagorean identity.
Yes.
A lot of people can't make that connection, so this is really good. Okay, so now I'm going to distribute
Yes.
that through. Everybody okay?
Mm-hmm.
And what does it screen?
I'm going to try trinomial set me to one side, factor me.
Right, that's
Yeah.
right, that's what it screens. Does it scream that to you, Kalia? Oh, it does. Good. So I hear. So I'm going to bring the cosine squared over because I'm scared of the negatives,
Yeah.
right? So 3 cosine squared plus 4 cosine theta, and I'm bringing the 3 over as well. So minus 4 equals 0. Check my work. I added the 3 cosine squared. I left the 4 cosine as it was and subtracted 3 from -1. Now, if I don't see that this is a trinomial that's easily factored, I can put x squared and x in there if I feel better with it. Does that make sense? So I could look at it as 3x squared plus 4x minus 4 equals 0 and unfoil it. But if you understand how to do that, you should see this works as well.
It's no different.
No, I don't think so. As you guys are getting a little bit more accustomed to it, it's not bad. So I know that I have 3 cosine and cosine, right?
Yes.
And I know my other numbers perhaps are going to be what?
-4, 1, 1, -4, -2, 2.
2 and 2.
Yeah.
I think 2 and 2 is going to be what we want, right?
Yeah.
So 2 and 2,
One's negative, one's positive.
right? And my larger of the 2 multiples, it's going to have to be larger because this is positive. So 2 and 3 is a 6, and that's a 2, so it's going to be this guy is positive, if that makes sense. Yes?
How do you do the Berry method? Because I know that's a good way to...
Oh, that's what I use for this one. Do you want me to explain or just...
Yeah, that's, I mean, you're welcome to.
Do you want me to
Sure.
show you?
Do we have
I
time?
just do it in my head.
After this?
Okay.
After this one, or do you want me to show how to do this one with Barry?
Do it.
Alright, this is what I did. You do... If you have regularly the 3 cosine squared plus 4 cosine minus 4, you start the parentheses, you place whatever's in front of the squared thing, the number both times, like that.
Okay.
Then you look at this sign, you know one's got to be plus, one's got to be minus.
Yeah.
And then you say, you multiply A times C, and
Yeah.
you get 12. So you need to think, what factors of 12 can add up or subtract to get 4? So that's a 6 and a 2.
Will be
Positive
negative.
6,
Yeah.
negative 2, and then you can factor out a 3 from this one, and just cosine plus 6, and then throw away the 3, and there you go.
Yeah, okay. So... Okay. Yeah. Or you can use the quadratic
Or
formula.
you can quadratic formula it.
Okay, so we've got cosine equals 2/3, cosine equals -2.
Uh-huh.
So now what? It wants me to solve.
Look at the unit circle.
Know where it's located?
Yeah, because like with the 2/3, cosine's positive, so know where those quadrants are, and the cosine's negative there, so know where that is.
So yeah, unit circle wise, where is cosine positive in the unit circle?
Cosine is, let's see, cosine is
Here.
There
and there and
Wait.
the
underneath
Fourth one, 4.
yeah
Cosine, your x's are your cosines. So your x's are positive here and here, right?
Yes.
Okay, and where is your cosine negative? Your cosine negative would be here and here. So the
Yeah.
answers that would match with this guy would be in the negative land, and the guys here would be the positive land. So let's go ahead and yes.
may point something out. That's not a solution because
domain error.
when you do cos to the -1 of -2, it says domain error.
It says domain error.
Yeah,
Yeah.
so that's...
So that's not even an option. Well, that's good news.
Yeah.
So we can eliminate this as one of our options. So now what?
So what do I do? Mark cosine. Choose Gosh.
So when you do the inverse.
Yeah, on your calculator. In degrees, right?
Yes.
Oh, okay.
48.2.
Yep.
And then you gotta find the other one. By
Okay, so 48.2 is in here. Do you
Yeah.
agree? It's between here and here.
Yeah.
Did you agree? So it's about like right here. Where
Yeah.
are you going to find the other one? Yeah.
Well, you have to find a reference line, don't you?
Mm-hmm.
And it's between 0 and 360, but it can only be in both two quadrants because cosine is positive. So you would say, how far is 48.2 away from 90 degrees?
Okay, so how far is 48.2 from 98
I
degrees?
just do it off of 0.
You can do it off 0 as
I
well.
just take 0 minus, or 360 minus that.
So you know from here to here is 48 degrees, 48.2.
Yes.
So from here to here is 48 degrees from that. So you do 360 minus that, and what do you get?
311.8?
Why'd you make 360?
Oh, well, I'll show you.
Oh yeah, like.
Are you sure? So that's a 1.
Yeah.
Not a 2. So it's the idea that it's 48 degrees from here, and I know the other answer has to be down here. So it's going to be 48 degrees from there.
Yes.
Does that make sense? Okay. Are we good? Yes.
Will they ever say, like, go bigger than 360 degrees? You could say
But
that.
they will say between 0 and 180.
Well, they might say, be sure to use radians. Like
Or
they'll
they
say.
might go from negative 90 to 90.
Will they say use radians? Or
Yeah, because then it has
Yeah.
0 to pi.
Or 2 pi.
Or two
Right,
pi.
right.
0
And
to
this
2
answer
pi.
was in degrees.
Yeah.
So if it was radians,
Yeah.
it would say 2 pi or pi.
Does that help?
Yeah.
Okay. Are we comfortable? So far, we would have got 100. Right? Yeah.
This next one a party. It looks like a
Let's see
party.
if it's a party. It looks like one we've done.
Like a party.
But they were nice.
Because
Yeah.
one party.
They were very nice for this party. So, number 3, they put this really high up in the numbers. That's crazy. So, the diagram is x equals 12 over y squared minus 2.
Yeah.
The shaded region is bounded by the curve, the y-axis, and 1 and 2. Showing all necessary working and find the volume in terms of pi. So, your answer needs to have a pi in the end.
Yes.
When the shaded region is rotated 360 about the y-axis. So, it is a party, right?
Yes.
So everything is in terms of x. Right?
Everything must be in terms of y.
And there's no hole.
X equals.
X equals, right.
Okay.
And there's no hole.
it already says it.
It's cool. They let it. They really
They
did.
did that for us.
So we know it's pi from A to B
Yes.
r squared,
Yeah.
right?
Mm-hmm.
So what's our A and our B in this case?
1 and 2.
1 and 2. They were really, really nice.
Because they gave it in terms of
They
y.
gave it in terms of y. That's really cool. You guys see it?
Oh yeah.
1 to 2. Otherwise, it would have been 1 to whatever, you know?
Mhm.
Okay, so then, and we know that it's, would you agree that the ceiling is this thing here? Like if you drew your person, so your ceiling is here, your floor is here. Because it's rotating about the place at which it's touching. So it's 12 over y squared minus 2
Minus 1?
minus 0.
Well,
You're on the axis.
oh, yeah, never mind.
Minus 0. So do I have to put minus 0?
No.
Squared.
Yeah.
Right? Are we good? What did I forget?
Little dx
Oh, a little dy actually.
or dy.
What did I forget? Oh, I put a pi in front, so I'm good, right? I didn't forget my pi, yes.
What is squared?
Because it's pi r squared. It's the radius squared.
It's just the formula, yeah.
Yeah, the formula. So, people made a mistake on squaring this, actually.
You got a factor
You gotta FOIL her out.
oil.
Yeah.
Reverse.
Right. I know, I hear you. So, it's going to be 144 over y to the 4th,
Yes.
and then minus 24
Over y squared.
minus
Minus.
24 over y squared, so minus 48
Over y.
over y squared plus 4. Right?
Mm-hmm. Hmm.
Now we integrate, but we don't know how to integrate with something in the denominator, so what do?
Move it to the top.
Yeah.
Move them to the top. So if I rewrote this,
We do know how to, but we choose not to.
we choose not to.
What's the last number?
I'll move out of the way. plus 4.
Yeah.
Looks like a 5. Yeah.
So in theory, you never have to do quotient rule because even if it is like a big thing in the denominator, you can bring it up and do chain rule.
Yeah. To the negative whatever.
Yeah.
Never remember that.
Pretty cool though. Okay, so integrate. So we have pi 144 y to the
-3 over -3.
perfect. Is everybody okay with that?
Yeah.
Add one whole, put it over itself.
Yes.
Integration. You with me, Clea? And then minus 48 y to the -1 over -1. And then plus 4y
Yes.
from 1 to 2. Does 145 divide by 3?
Yes.
Yeah.
-48.
Negative 48.
Plus 48y to the -1.
So I'm going to write it.
You have to
Can I write it right here?
48.
So pi times, we've got, you said negative 48 y to the -3, right?
Yes.
Plus 48 y to the -1 plus 4y. And my preference is to see those y's down below. So over y cubed over y plus 4y from 1 to 2.
Mm-hmm.
Is everybody good?
Yeah.
Clea, did I lose you?
Yeah.
Where? We integrate. We integrated. So at -4, you add one whole, which is -3 over itself. So that's where that came from. And then you add one whole over itself. And then you put a y there because there wasn't one with it. Y to the 0. All right. And then I said that divides into there evenly. So I just cleaned it up a little bit.
Yes.
So if I put 2, I get 8, 48, negative 48 over 8.
-6.
So when I plug in 2, I'm going to plug it in all the way across. So I've got pi times -6
Yes.
plus 48 divided by 2,
24.
24, plus 2 times 4, 8,
Yep.
minus.
But 1.
Now I'm going to plug in 1 in every single one of them.
Yeah.
So I've got negative 48
Negative.
plus 48 plus 4. So you have a string of things to be added or subtracted times pi. So you've got -6 plus 24 plus 8
Plus
plus
4.
48
Minus
minus 48
Minus 4.
minus 4. Because that negative has to distribute.
Where did you get the -6? Oh, you plugged
I plugged in a 2 in. Yeah.
Okay.
Yeah.
Got 22 pi.
Yes. It turned out kind of pretty
Yeah.
for all that.
We gained 5 points.
That's really not a bad 5 points. My hope is that you guys, number one, say, I know I've seen this before. You know, I have a little comfort level with it.
Yes.
So far, I think 1, 2, and 3, you've seen. You're comfortable
Yeah.
with. Right now, that would be what? 12 points. Right? All right. Cool. Number 4.
Related rates. And it says rates.
It said rates.
So it'll be dy over dt equals something dx over dt?
Right.
Wait,
Good.
so remember
Given equation, fine.
That's right.
we did the given. Is this the one where we broke it down into given equation and what we're trying to find?
Yes and no. Because this one already gives you dy dt, right? They give you dy dx, right?
Yeah.
A point P moves along the curve in such a way that the x-coordinate is increasing at a constant rate. It is, but they're already giving you the derivative. Does that make sense?
Yeah.
It's not in terms of t, but you just put it in terms of t. So it's one less step that you have to do. But it is a given Feynman equation. Yes.
So point 3 is dy over dx?
It's dx over dt.
Oh, okay. You dx over...
Okay. Let's break it down.
And then you just clean it up.
Right. So, because this is what we call a related rates problem, right? Because it's something that's changing, related rates, rather than dy over dx equals, I'm going to say it's dy over dt is equal to 2 minus 8 times 3x plus 4 to the negative 1/2 dx over dt. So what did I do?
You just move them over?
Yeah, I just took the dx and multiplied it over and said it's done with respect to time. So I put a dt under each of them.
Okay.
So now a point P is moving along a curve in such a way the x coordinate is increasing. So dx over dt is changing at 0.03.
0.3.
Thank you.
Yeah, the 0 before is deceiving.
I would have changed it, yeah, it's the old people eyes. Now, find the rate of change of y. What are we trying to find? We're trying to find dy over dt question mark when P crosses the y-axis.
So then x is 0.
So x is 0.
Yeah. You just plug and chug.
It's not a bad problem. So we're going to take everywhere we see a dx over dt at 0.3, everywhere we see an x, a 0, and we're going to eventually plug that in and get what dy over dt is.
Yeah.
So we have dy over dt is equal to 2 minus 8 times 3 times 0 plus 4 to the negative 1/2 times 0.3.
Mm-hmm.
That's really not a bad problem. Typically what they have, this problem is a little different than what I taught you, because normally I give you a y equals graph, and then you have to take the derivative, then do this. This one you don't have to take the derivative, they're giving it to you,
Yeah.
which is really nice. So what does this answer turn out to be? dy over dt equals 2 minus 8 times
4.
4 to the negative 1/2. So 1 over 4 to the 1/2, 1/2,
Yeah.
right?
So it's 8
1/2. Yeah.
Times 0.3. And 0.3 actually is to the whole thing.
Yeah.
So I really should put parentheses around that and do that first.
Okay.
So 2, that would be 8 times 1/2 is 4. 2 minus 4 is negative 2. Negative 2 times 0.3.
Negative 0.6. Right.
Oh, okay. I think
Yeah.
I did something wrong.
Okay.
What did you do?
0 times 3, 0. How did you get?
This whole thing is done before you multiply by 0.3. Does that change it? Yes.
Or choose dy over dt and dx over dt.
We're using those because it's something is increasing, changing over time.
Related rates.
Yeah. Okay, so are we okay?
Mm-hmm.
That was worth 2 points. So it wasn't supposed to be terribly difficult. And I think the reason why it's worth 2 points is because you didn't have to take the derivative first.
Yeah.
Does that make sense?
Mm-hmm.
All right. Now the next thing says the curve intersects the y-axis at the point 4,3. Find the equation of the curve.
Great.
What is it?
Integrate.
It's an integral?
Plus C.
It's a plus c. Why not an a and a b?
Because it's an indefinite integral.
It's an indefinite integral. Right. So, are we okay to erase this? No, maybe?
Wait, what did you say for that one?
Okay, so for the next one, they're giving you the derivative, right? And they want you to go back to the original function. So how do we go back to the original equation? Well, we have to integrate.
Yeah.
And they give me the ordered pair without really saying they're giving me the ordered pair, but they're saying the curve intersects the y-axis at y is 4/3. So what's the ordered pair?
0.
Right, 0 4/3, right?
Yeah.
Okay, so my thing is dy over dx equals 2 minus 8 times 3x plus 4 to the negative 1/2, right? And so we're going to integrate, and our ordered pair is going to be 0
4/3.
4/3. I tried to put 3/4.
Yeah.
Okay, so if I integrate all pieces. Okay?
Yes.
What's the integral of dy over dx?
Y.
Right. Because I said so. That wasn't funny. Never mind. Nick, you're supposed to laugh at my jokes. Okay, thank you. It's funny, I thought. Okay, what's the integral of this?
It goes for the ride.
X.
Or no.
No, because it's like they're
2x.
individual pieces, so it is
Okay.
indeed 2x.
2x. Yeah.
Now, the 8 goes for the ride.
Yes.
Yes.
So minus 8, right? That's just going to go for the ride.
Easy substitution.
What do I have to do with that? The
Bottom.
easy u substitution stuff,
Yeah.
right? I do the u equals, Kalia and I do the u equals 3x plus 4, and we do our little fun stuff.
Yeah.
The rest of the world does it the easy way.
Yeah.
So how do the rest of the world do it? They go 3x plus 4, add 1 whole
To the 1/2
to the 1/2,
And then all over.
all over 1/2,
times the derivative of the inside.
which is
3.
right. Then what do I do?
Clean it up. Oh, plus C.
Don't forget plus c. Okay? So does anybody need help with how that happened? Okay? And does everybody recognize that we had to use it? That's part of the battle. So do you guys agree that this is 3/2 on the bottom, which flips up as a 2/3?
Yeah.
Right? So really 2/3 times that would be 16/3. Does everybody
Yeah.
get that? So this is 3/2.
Yeah.
So if I flip it up, it's times 2/3.
Yeah.
2/3 times 8 would be 16/3.
Yeah.
Right? So can I just write that? For sake of... Yeah? Now I'm going to plug in, what am I going to plug in? I'm going to plug in everywhere I see an x, a 0.
Yeah.
Everywhere I see a y, a 4/3.
Uh-huh.
Is that 3's over that whole
It's,
thing?
yeah, 16/3. It goes under it, the whole thing.
Yeah.
So I've got 4/3 equals 2 times 0 minus 16/3 times, really, 0 plus 4. So
4.
4 to the 1/2 plus c. Are we feeling it? Okay, so this is 0. That's nice, right? 4 to the 1/2 is 2.
Yeah.
2 times 16/3 is 32/3. Everybody okay?
Yeah.
So really what I have is 4/3 equals negative 32/3 plus c.
Uh-huh.
Add 32 to 4.
36/3, which is 12.
Yeah. So c is 12.
And then you just reinsert that.
Right, so they're looking for the actual equation of the curve. The best place to put it is right here. You know, you make it look pretty. Y equals 2x minus 16/3, 3x to the 1/2, plus 12.
Mm-hmm.
Is everybody good? So y equals 2x minus 16/3 times 3x plus 4. Are in this vast world of math, you have seen every single one of these top 4 questions, right?
Mm-hmm.
They're not, at least, they're not something you feel like you've never seen. All right, number 5. A farmer divides a rectangular piece of land into 8 equal-sized rectangular sheep pens, known as shown in the diagram. Each sheep pen measures an X by Y and is fully enclosed by metal fencing.
Mm-hmm.
Okay, so the farmer uses 480 meters of fencing.
Mm-hmm.
Show the total area of the land used for the sheep pens is given by.
Hmm.
The total area of the land used for the sheep's pens. All right, how do we begin this problem? What is a given? What's a known fact here? Yes. The area formula is a known fact.
Yeah.
We know
What else do we know?
We know the height is 2y and the length is 4x.
Okay. But what is 480?
That's the
Perimeter.
perimeter.
All those
Of-
lines.
All
Of-
those lines.
Yeah.
You guys agree?
All the lines.
So really, what is 480? Remember when we did these, you have an equation that's a full equation,
Uh-huh.
and then you have an equation that's kind of a partial equation that you use in a minute? Does that sound at all familiar? So if 480 is our perimeter, it's going to be this plus this plus this plus this, right?
Yeah.
Plus this, etc., 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 all the way across until you have all pieces.
So it's 10y and 12x.
Because it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10y. Right. So let's go that route. So we are taping this for you guys to go home for your viewing pleasure. You're so welcome. Right now we're working on, I don't even know, May, June 2016. Was it May, June?
May, June 2016.
Paper 1-1.
Yeah.
Okay. No,
No.
this is one that you will have, like, we're just kind of talking about it, going over it, making sure. The first 4, I think everybody's in agreement. They've seen it all, at least seen it. So, in this case, we're starting number 5. Number 5 gives you this farmer's land. These are all fenced-in areas. They're telling you for certain that they're using 480 meters of fencing. So we talked about it and decided that that 480 meters of fencing means perimeter of all those little fences together. And so we decided that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 Ys.
Yes.
And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 X's.
Mm-hmm.
So 12X plus 10Y equals 480. Agreed?
Yeah.
That's the equation that is 100% certain. The other equation that they're going to want, because this is the one that you have to use 2 equations. One's full and one's partial. You solve for one and plug it in the other. You can remember that. Okay, so let's look. The next one says, show the total area of the land used. Well, how do we find the area? Does the middle fencing matter for the area? The middle fencing doesn't matter. It's truly this by this.
Yeah.
Do you agree? So what is this?
4x.
1, 2, 3, 4 X's times
2y.
2 Y's. So 4 X's times 2y is going to be equal to the area.
Yeah.
And it says show that the total area is given by that. Okay? So what do we have going on here? The answer that they want me to have is all in terms of x.
Yes.
Okay? The area that I have here, would you agree, if I clean it up, is 8xy.
Yeah.
Not quite what I need.
No.
I need everything in terms of x. So how do I do that? Well, do you see that if I solve for y in terms of x, I can get everything in terms of x and plug it right in here for y?
Mm-hmm.
Does that sound familiar?
Yeah.
So what is this here? I'd have 10y equals 480 minus 12x.
Mm-hmm.
Y equals 480 divided by 10 minus 12x divided by 10. What does that clean up to?
48.
48.
6 over 5.
6/5 x. Coming. So everywhere you see a y, stick that in there.
There's no X.
Hello? Yeah. But it's how are we feeling so far? So if I took this and I plugged it in, right? Because the question they want us to have has absolutely no y's in it. So I know that I'm going to take 8.
I have a question.
Go ahead, yeah.
Is it? Oh, never mind. You erased it.
Huh?
Never mind.
I erased it?
But there was like a 48. You had
48
X next to
so
48.
you erased it.
I didn't mean to.
Yeah, I know. So
I got
just wanted
excited,
to
put
make sure.
X's there. Right?
Yes.
And then you just distribute, clean her up a little bit, and it will look just like that.
384x, and then the 8x times negative 6/5 is going to
Right.
How did you take out the Y?
Because I solved for y in terms of
Oh,
x, and
yeah,
I plugged
yeah.
it in.
You plugged
Right?
it in.
Okay, we'll finish tomorrow.
be finished tomorrow.
Yeah.
Okay.
What do you think?
Good.